Hello, this is Ali Kotami with SCS Engineers. Thank you for taking time out of your busy schedule and listening to this presentation. The subject of the presentation is perforated and non-perforated centralizers on double-cased pipes. We are going to very briefly discuss about the use of centralizers. Centralizers are normally used in double-cased pipes. When you have a main carrier pipe fitted inside a larger pipe, which is considered as casing pipe, a centralizer is needed at some point along the pipe. Here in this presentation, I'm going to be referring to these pipes as inner pipe or carrier pipe or casing pipe or outer pipe. So these are the terminologies that normally come about when we talk about the double-cased pipes. Double-cased pipe, the inner pipe could be a leachate force main, and the casing pipe is intended for disallowing any leaks from the main carrier getting into the environment. The purpose of the casing pipe is to catch any leaks that may happen through one of the valves or a defect in the main carrier, and take it to a monitoring point that the operator would know whether there is a leak from the main carrier. Centralizers are normally used at locations that the two segments of a double-cased pipe gets butt fused together, and the purpose of the centralizer is to align the inner pipe, two segments of the inner pipes, and align the outer pipes properly for butt fusing of the pipes together. Location of centralizers for alignment purposes. Double-cased pipes may be constructed segment by segment, meaning pipe segment by pipe segment. In that case, a centralizer is needed at segment length along the pipe when they put these segments together. Or double-cased pipe may be constructed in long pipe sections, meaning the outer pipe gets welded together, pipe segments get welded together on a very long length, maybe 1,000 feet long. And then the inner pipe gets welded in the same fashion, 1,000 feet long, and then they push the inner pipe inside the outer pipe. That becomes one long section of a double-cased pipe. And the contractor may build another long section similar to the first long section at a different time, at a different occasion, and then at some point these two long sections have to be welded together, and that's where a centralizer is needed to align the inner pipes and outer pipes properly for butt fusing the two long sections. There are two types of centralizer. There's a perforated centralizer and a non-perforated centralizer. I'm gonna go through the descriptions and some pictures of this. This is a perforated centralizer. As you see, there is an interior pipe that the circle of the interior pipe is visible here in the middle. There is an exterior pipe and an outer pipe or a casing pipe, which is a larger pipe, and the circular thickness of that pipe is also visible. In between the two, there is a slab that is the centralizer. And as you see, this centralizer is perforated. There are holes at 90-degree angles in this slab, which allows flow in the casing pipe outside the main carrier to flow through the casing pipe. This is a non-perforated centralizer. It resembles the other one without the perforation in the slab. The outer pipe and the inner pipe and the slab in between is non-perforated. In this case, this is a prefabricated centralizer that will fit inside the piping system at some point. But the slab is non-perforated, which acts as a non-perforated centralizer. Perforated centralizer are used to allow flow in the casing pipe outside the main carrier to take place. Meaning, if liquid comes out of the main carrier in the form of a leak from the force main, gets inside the casing pipe, and has to flow a certain distance before it gets to a detection chamber, the centralizer has to be perforated to allow the flow to take place through the outer pipe. Non-perforated centralizers, on the contrary, prevent flow in the carrier pipe at certain points. And there is a purpose behind non-perforated centralizer, which I'm going to get to it. Perforated centralizer are used for long double-cased pipes with a detection chamber or a detection instrument somewhere along the pipe. So like I stated earlier, if liquid gets out of the main carrier and goes into the casing pipe, the liquid has to be able to flow all the way to the detection chamber or detection riser at some point along the pipe. And as part of the regular landfill operations, the operator monitors the detection chamber or detection instrument to see if there's a liquid in the casing pipe or in the chamber. If they detect the liquid in the chamber or out of the detection instrument, it is an indication that there is a leak from the main carrier getting inside the outer casing pipe and reaching the detection point. At that point, the operator has to take actions and find the leak in the force main. That part of the work is outside the scope of this presentation. I'm not going to get into it. This is an elevation view of a typical detection chamber. In the middle of the slide, a vertical HDPE cylindrical manhole is presented. That's the chamber that we use as detection chamber. For the moment, just ignore the concrete structure around it, and I'd like to bring your attention to the pipes on either side of the chamber connected to the chamber. These pipes are a double-cased leachate force main. The inner pipe, which is a smaller pipe, is the main carrier of leachate that passes through the chamber without draining into the chamber. So the chamber is a kind of dry chamber. But the casing pipes stop on the inside wall of the chamber. If there is a liquid in the casing pipe in the form of a leak from the main carrier, the liquid drains into the chamber, and the regular monitoring of the chamber will show that there is a liquid in the chamber, and that's an indication of leak from the main line. This is the same concept but actually being implemented in the field. The black HDPE vertical pipe, large pipe, is a detection chamber, and the pipe that you see in the foreground of the slide is the double-cased leachate force main. You only see the casing pipe, which is a larger pipe going into the manhole. The carrier is inside this pipe, which extends through the manhole, but the casing pipe stops, terminates on the inside wall of the manhole. There is a similar pipe on the other side of the manhole. If you look closely, you see that in the background of the slide. The other piece, also the casing pipe, stops on the inside wall of the chamber. If there is liquid in the casing pipe, on either side of this chamber, the liquid flows inside the chamber, and the regular monitoring will detect that. And if there is a leachate inside the manhole, then there's an indication of a leak in the main carrier. This is actually during the construction, which shows there is a centralizer is placed inside the casing pipe, and the main carrier is fit inside at the center of the centralizer, and the centralizer is perforated. It comes on site with the perforation built into it. In this slide, the crew is installing the centralizer, which is a perforated centralizer, on the double case pipe. The inner pipe is fit to the center of the centralizer, and the centralizer itself needs to be fit inside the casing pipe. Sometimes you would have to use prefabricated couplings on your double cased pipes, and the errors can happen, and a piece may come on site that is supposed to have perforated centralizers in them. When the crew or the CQA person finds out that the centralizer is non-perforated while it should be perforated, then we end up drilling holes in the non-perforated centralizer to make it perforated centralizer, which this slide is one of those cases. The centralizer that you see here was supposed to be perforated, and it came on site as non-perforated, so they drilled holes in the centralizer to let the liquid pass through. And this is another case of a large double-cased coupling, which is a T, and the perforated centralizer is visible on one of the kind of legs of the T. Non-perforated centralizers are used at specific locations identified by the design engineer on the casing pipe. A good application of non-perforated centralizers is to isolate a section of the force main for when it comes to identifying location of a leak. For example, if you have non-perforated centralizers on a double case force main at the outer boundaries of a cell, with a chamber, a detection chamber or a detection instrument in the middle between the two non-perforated centralizers, if leak is confirmed in the chamber or through the instrument on that segment of the pipe between the two non-perforated centralizers, then the operator would know right away that the location of the leak has to be somewhere between the two non-perforated centralizers, because the casing pipe is isolated between the two non-perforated centralizers. On the contrary, if perforated centralizers are used in the casing pipe and a long segment of the double cased pipe drains to a detection chamber, and a leak is confirmed inside the chamber, it would be a very difficult task to find the location of the leak from the main carrier into the detection pipe, because if the perforated centralizers allow flow through the entire long segment of the pipe into the chamber. So the detection of the location of the leak is more complicated and more cumbersome. Now I'm going to show you the detection instrument. On the lower left corner of this slide, it is visible that a double cased pipe is coming vertically up through the floor of this concrete structure into the interior space of the structure. The casing pipe stops and the main carrier goes through a blind flange, if you will, and extends inside the structure. Right on top of that blind flange, there is a vertical pipe connected to a valve. That simple valve acts as a detection instrument. If you open the valve and liquid comes out of it, it means there's a liquid in the casing pipe out, and it's an indication of a leak from the main carrier. This simple instrument replaces the detection chamber that I showed you earlier. Over the past few years, we have converted all of our designs from a detection chamber to a detection instrument, which is much easier to install, and we save a lot of cost for our clients by switching over to detection instrument. With that, I conclude my presentation, and I thank you for taking time out of your busy schedule listening to this presentation. If you have any questions, please don't hesitate to contact me on my cell at 561-441-1473 or via email. Thanks again.